So here we have part 2 of simplifying radicals. And so as we look here and simplify these radicals, I want to make sure that we are looking at the 3 rules that we started out with, where we do not want any perfect squares left. We do not want radicals in the denominator of our fraction, and we don't want the whole thing in a radical form. So example 1 is simplifying the fractions here that are already in radical form. So let's go ahead and we can break that apart. Fraction means division. So we can write that as the square root of 64 over the square root of 49. And these are actually both perfect squares. So what is the square root of 64? It is 8 divided by, what's the square root of 49? It is 7. And that's your final answer. It's a fraction, it's 8 over 7. So again, perfect squares make things so much easier. So look for all those perfect squares. Let's go ahead and look at the same kind of problem, but a little bit more in depth with example 2. Example 2, I'm going to go ahead and kind of write it out for you here. I would have, or what I see, I should say, is I see 8 times x times x times x divided by 50 over x. And when we go back to think about simplifying with fractions, with letters, x divided by x, we know that can cancel out and it's 1. So we can cancel those out. And then I also see that I have an 8 and a 50, and I could divide both of those by 2. They're both divisible by 2. And you're going to see what happens since we did that. So it's the same thing as, sorry, I can't get my pen here. It's the same thing as 4x squared all over 25. And again, we are trying to get rid of the radical in the bottom of the fraction, or the entire thing being in radical form. So let's just write it out as the square root of 4x squared all over the square root of 25. Well, we know 4 is a perfect square, so that's going to come out of the radical. That's going to be a 2. We know x squared is a perfect square. X times x is x squared, and the square root is just x. So that comes out of the radical. We know the square root of 25 in the denominator is a perfect square. Square root of 25 is just 5. And with that being said, you have simplified this. You no longer have any radical symbols. You're in simplest form. So sometimes we need to look and see what can we divide the top and the bottom of the fraction by. And here it was divided by 2. So on both of these examples, we have simplified them. We know it is simplified correctly when you no longer have a radical symbol in the bottom of a fraction, or the entire fraction is in a radical symbol, and you've gotten rid of all of your perfect squares underneath the radical. Let's look at our last example. And so what happens if the bottom number of my fraction isn't a perfect square? That's what we're going to look at next. And what we do when we know that bottom number is not a perfect square is we have to do what's called rationalizing the denominator. We got to get rid of it. So with that being said, if I look at my first example, the square root of 3, well, that's a prime number, and the square root of 7. The reason we do not like this, we can say this is not simplified, is because the bottom of the fraction has a square root of 7. Can't have a square root in the bottom of a fraction. So we need to rationalize the denominator. The easiest way to do that is we're going to multiply. Now remember, whatever we do to the bottom of the fraction, we need to make sure we do to the top to keep it equivalent. So we're going to multiply the bottom and the top by the square root of 7. And so what happens here is in the numerator, you have the square root of 3 times 7. And in the denominator, you have the square root of 7 times 7. And so what you just created here in the bottom is you created a perfect square. 7 times 7 is 49, and the square root is just 7. And so your final answer for this one would be your square root of 21 in the numerator. There's no perfect squares up there. You have to leave the square root of 21 in the top of the fraction. That's okay. And in the bottom, you have just a plain old 7. So that is simplified because we got rid of the radical symbol in the bottom of the fraction. Let's look at our very last example. This example, we know the top number is a prime number. But if I look at this bottom number, the square root of 8n, 8 I know I can break up to a 4 and a 2. 4 times 2 is 8. And I know 4 is a perfect square and it can be broken up to 2 times 2. I don't like that I circled that, so hang on one second. There we go. 4 can be broken up to 2 times 2. So if we circle everything that is going to get us the number 8, 2 times 2 times 2, times that n, we now can look at this problem as the square root of 7 over the square root of 2 times 2 times 2 times n. And we can pull out our perfect square. So now we're left with the square root of 7 over 2 square root of 2n. Well, we're getting closer, but we still have a radical in the bottom of our fraction. So this is where we need to rationalize the denominator. We need to get rid of that radical. So to get rid of it, we're going to multiply by it. Whatever's in that radical, that's what we're going to multiply by. And so now in the numerator, you are going to have a 7 times 2 times n. And in the denominator, out front, we're going to have the 2. But then in the radical, we're going to have a 2, an n, and an n. And when we go to simplify that, we know that 2 times 2 is a perfect square. So the square root of 4 is 2. And we know n times n is a perfect square. And n squared, the square root, is just n. And so your final answer, I got a little sloppy here. Your final answer, the top of your fraction is going to say 7 times 2 times n, which is 14n, under the square root symbol. 7 and 2, 14, not perfect squares. They've got to stay there. Divided by, we've simplified our denominator. 2 times 2 is 4, and the letter n. And that would be your final answer, completely simplified. And why is it simplified? Because there is no radical symbol in the bottom of the fraction. Hope all is well. Take care.